Okay, with this example, it's kind of worst case scenario, I guess you'd say. Here we have the equation of a line, and it's in parametric form, so that's a plus for us. However, the equation of a line is given to us in vector form, and the vector form not always the most agreeable form to work with, especially when our strategy is to go through and use the standard form. So what we need to do is create a standard form equation for the plane. So standard form, in order to do that we need the normal. The normal comes from taking the cross product of the given two direction vectors. So D1 cross with D2. So we need to find cross product of 1, negative 2, 2. Crossed with 1, 0, 3 in order to successfully finish the question. Oops. So off to the side here doing the cross product. Getting ahead of myself. 1, 0, 3, 1, 0, 3. Crossing out the first and the last. So the resulting vector will be negative 6, take away 2, negative 8. And then 2, take away 3 is negative 1. And then 0, take away 2, so that'd be a positive 2. So now I need to determine the equation of the plane in standard form. So I now have the A, B, and C value. I have my normal values to plug in. Point on the line is given. It's our reference point. So plugging in the values for ourselves here. And Z values of 2. So I'm looking for my constant. So negative 16 minus 1 plus 4 plus D equals 0. So D will equal, so what do we end up with here? Negative 12, negative 13, 13. So there's our constant. So all we have at this point is the equation of our plane. Minus y plus 2z plus 13 equals 0. So we haven't even got to do the substitution yet to determine that point. So, but now I have a normal to work with here, because now I can come over and now I can do my check. And the check here, and I really, at this point here, I guess I didn't have to find the rest of the equation, because if the check proves that this is parallel or coincident, what I did below was kind of a waste of time. Still, we'll go ahead, and the normal was negative 8, negative 1, 2, and my direction vector is 1, negative 2, negative 5. So solving that, negative 8 plus 2 minus 10. So by the look of that, it's not going to equal 0. So what I did was worthwhile. So intersects at a point. So down below then, I can now go ahead and solve, except I need my parametric form, which is a little bit inconvenient at this point in time. Minus the y1, negative 1 minus 2t, plus 2 times negative 3 minus 5t, oops, plus 13 equals 0. And now I can go ahead and finish this question as we've done with the previous example. So negative 16 minus 8t plus 1 plus 2t minus 6 minus 10t plus 13 equals 0. So my t is negative 8, negative 6, negative 16t. And my numbers, negative 16, and that's going to make me negative 3, negative 9, negative 8. Move it to the other side, becomes positive. So my t value is 1/2. So therefore, from the given equation above, where x is equal to 2 plus t, y is equal to negative 1 minus 2t, and z is equal to negative 3 minus 5t. Putting a half in for those, we get 2.5 for my x value, and negative 2 for the y value, and that's going to be negative 2.5 minus 5.5. So there is the intersection point of this line and plane. So the only thing that was new or different here was you had to actually come up with the equation for a plane in standard form. So it's a worst case scenario or a kind of a nasty question with respect to that. It's more workload wise than actual that part of the thinking. So homework's there. If you need any help, oops, you know where you can find me, and we'll talk to you in class.